Right, so let's go. This is my assignment 3 submission for COMP3132 Applied Machine Learning. This is Jay Kumar and my student ID is 101236674. So this is the data we already got. This is the image that we have using the color channels and then getting this white Lamborghini. So now we'll define the functions like squashing pixel values, COMP2D kernels, stuff like that. And we will get started with line detection. So for line detection, we are using the array and we're detecting this specific pattern. So for horizontal lines, the middle line is 222 and then -1 on the top and below. So this is the solution for that. And now we will be using this slant kernel, which is for the detection of images at 45 degrees. So this way, like from bottom left to top right, and for 135 degrees from top left to bottom right. And this is how it looks. This one is more defined as compared to this one. This is a bit dull. Now for edge detection, we'll be using the arrays that were given to us by the professor, and this is the result for the first one. It is very feeble image. It's not that defined, and it's not that sharp. For the second one, we get a better image with more defined lines, more defined structure, and it is darker than the previous one. And this is the best of all three. This is the third array that we got, and it is very defined, and it is sharp, and the lines are good. So now this is the second part B. We'll import the libraries and the layers, and let's get the data set, then convert the data set into categoricals and get normalize and convert the train and test images from integers to floats and normalizing the range 0 to 1. So we have this model, right? And then this is the summary. We have a COMP2D layer, a max pooling 2D layer, flatten, and two dense layers. And now we have this custom callback function defined already, custom like pre-coded. So first of all, we will get the data from the model that we have and we'll fit the data into the model. So for this one, it started out low, and around this point it got stuck into a bottleneck. Although the training accuracy kept getting higher and higher, which might be because of the unnecessary noise or patterns in it, while the accuracy after this one, the validation accuracy, it was fluctuating around the same path, which which it can be called as overfitting. So yeah, the network presented signs of overfitting and around the 10th epoch. So we have 5 layers: COMP2D, max pooling 2D, flattened, dense, and dense. Last two are dense layers, and the purpose of each layers is right here. COMP2D layer creates a convolutional kernel. The second layer is to reduce the dimensions of the output volume to make it a bit more compressed and like easier to study the data. The third layer is flatten, which takes the array of the data and converts it into a single dimensional flat layer. And the last two layers are just the most basic layers in Keras in the Keras library, and yeah, it just pushes the data into the neurons and provides an output based on weights and biases. Alright, so for the sixth one, we were asked to add another convolutional layer. I changed it a bit, and instead of 32, I used 128. And when I ran that, it definitely had higher accuracy, the validation accuracy, than the previous one, but it also reached a bottleneck around the 10th one, while the training data was getting more and more accurate. It's almost reaching 1 at some point. Now, yes, as you can see, it is Oh, the overfitting kind of starts here, but this is the highest limit, I guess. So yeah, this achieves a higher validation data accuracy as compared to the previous model, but it still overfits. Now for the last one, we were asked to add a dropout layer into it, so I added a zero point 0.5 dropout layer into it, and because of that, we achieved a higher accuracy. But the same thing as before, we kind of ran into overfitting around 15th epoch, which is better than before. So here is where we ran into overfitting, and then the data was just like almost constant all the time. So accuracy is better, and it keeps on improving steadily, like as compared to the two previous models before. And for the last one, we were asked to modify hyperparameters to improve the accuracy. And so what I did was I dropped out zero point 0.8 value of data because it was evident that it has the data has the model has too much noise in these ones, so it gets back into training data. That's what's not working out for it. Also, I made this dense layer 512 neurons thick. So let's go. And yeah, as we can see, the validation accuracy is higher, although training accuracy is lower, which means it did not overfit the data. It's almost a small difference. So yes, see, this is a much better representation. Still reached overfitting at some point, like 20th epoch, but we can see that it is closer, the both of them. So that is it. Thank you for listening, and hope you have a good one.